We continue with the next speaker. This is also a professor, Lars Ailo Bongo. He is professor in health technology at the Department of Computer Science at UiT, the Arctic University of Norway. He is the PI in the Health Data Lab. Bongo is also active in building a culture for entrepreneurship at UiT. Bongo has an adjunct professor position at Sami University of Applied Science, where he recently co-founded the Sami AI Lab that aims to use AI to improve the Sami society for the better. But today he's going to talk about the developing high-risk AI systems in mental health. Lessons learned from the Trusting project. Please.
Thank you. Do I need to turn on something here? Maybe this one. Now it should work, right?
Maybe just closer. Yeah.
Okay, now I hope everything is good. Great. So I decided to make one small change to the title, so it's my lessons learned from this project, because all of the errors, misunderstandings, insults, and so on are on me. So just like disclaimer. So in the Trusting project, so what we're going to do, are we going to develop this tool to predict basically or detect relapse for people with psychosis. And this is a worthwhile thing to do, trust me on that, but this is an AI talk, so let's skip that part of the motivation and rather talk about why this is interesting from an AI perspective. Which is that in psychology, language is the instrument they use both to diagnose and treat people. But the main challenge is that this doesn't really scale, like you need people for that, and there's just like a limited number of psychologists that are available. So one thing that scales is AI, and of course with the recent developments in AI like ChatGPT and Whisper for transcriptions, it seems to be like language seems to be more or less a solved problem, maybe. So for this type of field, so what we can do is like we have these tools and we add some decision trees, and it's relatively simple to implement then something like the tests they use to, for instance, detect this type of diseases. And this is actually what we are doing in the Trusting project. And we in this talk will be the Tromsø team, and we are responsible for building basically the infrastructure for doing all the data collection and sort of making this tool. And it consists of like two main parts. One mobile app, which is used to collect data, and then a backend system, which we have in a secure platform called TSD, where we do all of the analysis of the collected tests, and we have like human oversight that do sort of quality checks of the data. And the main aim is that we're going to build a clinical decision support system that gives sort of advice to the clinicians whether these people are relapsing or not. But most of the thing what we actually do in this project is maybe not what like generally is considered AI. So it's not about model development. It's all of the other things you need to do in order to actually make an AI system that's used in practice. It's about sort of the configurations, the infrastructures, the metadata testing, debugging, and all of these things. And also, like just to get back to sort of the tests, which sort of from AI perspective seems simple, and also when I start off this so it's like, how hard can this really be? So these are like 3 or 4 of the tasks we have in our app. So some are really simple. It's like just like, have you stopped taking your medication? Yes, then it's a red flag, and sort of then it's like a serious thing. Others are sort of sliders, like how well have you slept tonight, which is also really simple to analyze. But then we are like the things we are in the Tromsø team mostly interested in is the speech-based tests. And like you can see, like in the middle one, it's like the app will tell a really short story, sort of specially written for do the type of cognitive measurements that the test does, and then ask the person to retell the story. And another of these sort of speech-based tests is like name as many animals in 1 minute as you can. And that's sort of like, these are not that complicated, but actually implementing and using in practice is actually much more difficult than it seems. And now I sort of getting maybe more to the sort of what we have learned or what I have learned and sort of the challenges. So the first thing is that this is a really scary thing that we are actually doing, because this what we are trying to do is we try to detect that somebody has relapsed. And that meaning that person is not capable of taking care of themselves. The government can then sort of force them to take medications or put them into a hospital. And this is a video that shows actually one person that has relapsed recently is now sort of receiving treatment. Yes.
Hej Joakim. Tack för sist. Så har du det här. Du sitter inte. Nej. Ska vi ta oss en tur upp? Hej Joakim. Tack för sist. Så har du det här. Du sitter inte. Nej. Ska vi ta oss en tur upp? Opp eller opp? Ja, hun sa vi skal opp en etasje eller to. Ja. Han blir nå medisinert for å prøve å holde han litt nede, og medisin gjør at han har problemer med å snakke tydelig.
He's saying, as I guess that you got an impression on that. Yeah. So now I need to skip a few slides ahead. And also, like, since these are really vulnerable people, like there are strict regulations for what we can do and what we're not allowed to do. Sort of this is one of the high-risk applications that the AI Act covers. This is also like we're building a medical device, so we have to adhere to the medical device regulation, and there are also a lot of like ethical approvals that are needed to do this work. And this is as it should be, because this is, again, a scary thing to do. So we have some like design principles, and maybe the most important thing is trust. It's also in the name of the project, trusting, is that like this will never work if the sort of the patients or service users, as is the preferred term, don't want to use it. If they don't trust on the thing, they will not use it, and then we don't have any project and we don't have anything to build. So like our most important sort of designers is security, not actual security, but actually perceived security. Like we cannot be in a situation where like the service doesn't trust us, or sort of the clinicians doesn't trust us. So we also had the users co-design the app. So the second design principle is to reduce dropout. So we need to collect data in the study, and sort of the one big worry is that the service users drop out over sort of the year that they are being monitored. And like if they drop out, we have too few users to actually get the useful data we need. So that means that the app is actually designed specifically for that, like reduce dropout. It should be very simple to do, like it shouldn't take that many minutes to do per week, and sort of the task should be easy enough that people feel that they master. So a lot of care has actually gone into sort of the data collection part of this project, and that's the reason why there are like these tests are that as simple as they are, because these are things people can and want to do. So the third design principle is that we need to be multilingual. So these type of tests, they are language and culture dependent. So and we are collecting data from 6 different languages in 5 different countries. And like as one of the infrastructure developers, like one challenge for us is that we are working with language nobody in the teams know. Like 3 of the languages are Czech, Turkish, and Dutch, which we don't have anyone that speaks. The 3 others are English, French, and Swiss German, to make it more difficult for us. Yeah, and sort of like, and this has also been like one of the principles that we need to be multilingual in all parts of the app design, the analysis, and so on. And then some of the lessons learned in this project. This was like a really not great lesson to learn. So it was a medical device regulation surprise that we are doing something that will eventually become a medical device, but we learned at the beginning of the project we actually need to get some of this work done before we can start data collection. And that's sort of on the engineering time, we had to devote resources for doing this, and in an academic setting, like maybe sort of writing a lot of documentation and setting up workflows for the professional development is not what people are the most keen to do, but we are working on this. And as part of that is that we are building a machine learning tool. So we need to actually do that also in a professional manner. So this is maybe like how most research machine learning code is developed and used. Basically like you make a model, you put it on a server, maybe somebody uses it, and that's it. Whereas like this is images, by the way, from a blog post from Google, sort of how they think this so-called ML ops, which is the operation of machine learning, should be done. So this basically like there's a lot of stuff to be added to get this actually working in a manner I think is sort of necessary if you are doing with medical device regulations. And these MLOps, that's not something we do regularly in our academia. Like we, at least the machine learning community, like we are mostly focused on training models, not as much on the inference part, and certainly not in the part where there are real users using the system over time. Another lesson learned is that we are in a very small data domain, and collecting data is very difficult. So it's a very sensitive data. So these are like special categories, sensitive, vulnerable people, and so on. In this project, we have ethic approvals from 5 countries, plus Norway, although we're not collecting data here. And speech data is also very hard to anonymize. It's maybe impossible to anonymize. So it's not something you can make open access, or the availability of open access data is like almost non-existent. So the second lesson learned is that we actually have no data, that's real data in the project. So we are using synthetic data to do actually sort of the development of the tools and the infrastructure and testing and so on. And we're using a platform called 11 Labs to generate sort of synthetic voices. And these are some more like design principles that we have. So one is the humans in the loop. So human oversight, that is required by the EU AI Act. I think it's a bit uncertain like what that actually means. So we are sort of also developing sort of the good approach for doing that with the resources we have available. As I mentioned, everything runs in this TSD, a secure platform. So we don't have any internet service. We can't use like a big large language model unless we can install it locally on that service. And this is restrictive, but I think it's actually good for the MDR compliance. We don't have that many sort of external things to worry about. And then we start with what I learned today, maybe causal AI. So use actually like the expert insights to build the system, or start building the system. And this is also something we need to do because we don't have this data. So the data-driven parts will come later. And then I mentioned like language may be a solved problem in AI. So another lesson learned is that like transcription is not actually a solved problem. Like our service users, their speech is real, and as you heard from the guy speaking in the video, like it can be really hard to detect what these people are saying. So we can sort of assume that the transcription will be sort of work well. And there are also other issues that, in addition to speech impairments, is that we are working with 6 languages. One of them is Swiss German, that doesn't actually have a normed written language. And we also have like not regular English, but sort of Irish accent of English. This is the team. Should especially mention Britta Elvevåg, who's the PI at UIT. And we have like all of this work is being done by 1 engineer and 2 postdocs. This is what I've been sort of a summary of what I've been talking about. Like I started with saying that machine learning, like if you want to do this type of project, is much more than just the machine learning code. And I also hope that I motivated that in addition to this, there are many other needs when doing this type of project. And then I will sneak a bonus slide in while you ask the questions. I will not tell about this, you can read.
And now I think we will have room for questions. So, and if you could repeat the question, Lars, yeah, please.
Thank you, Lars. That's very impressive. And I wanted to talk to you about, so the whole idea is to create a device that people can monitor themselves, right?
No, they don't monitor themselves. There's a clinician that monitors the patient. So we never send data. Yeah.
Monitor remotely without having to go to the hospital.
Yes.
The text that you tell them to read, does it change every time? What is the usefulness of the text? Is that whether there's going to be changes in what they say in the story, so the story is always the same? I'm very curious to understand the clinical
So this is sort of the design of this test. It's a speciality in itself, and it's certainly not mine. But like our PI in Tromsø, like she is a specialist in this, and we have like this. The services will be monitored over a period of 52 weeks, and I think we have 13 different sort of stories that are repeat a couple of times, and they are similar in style, but they're sort of like the key elements that sort of can be used to detect whether they recall the important details in the story. Yeah.
And my second question was on the ASR, because I think also it's very close to your expertise, if I don't remember correctly.
So, Lars, if you could repeat the question,
yes,
yeah, please.
Sorry. Yeah, so the question is about the ASR, like how well it works, or?
Yeah, so can you, I mean, it's clear that in English it seems to work okay.
Yeah.
How do we scale it up for other languages?
Yeah. So ASR, it works well for English, and maybe like the Dutch and French for the big language, but when it comes to not even small language like Czech and Turkish, they are big languages in terms that they have many speakers actually, and how to make them work better is usually like this more data, and if it's a really small language as Sami, which I'm especially interested in, it's like just resources to do the work. Like many of these languages probably not have that many people ever work on them, and then also like in addition to this ASR, like ASR works well in English for sort of people that speak somewhat normally, or sort of service users. They have like this mumbling and this different speech impairment, and then even in English, like ASR may not have the performance needed for this type of like serious high-risk AI.
Another question here.
So first of all, thank you very much. Really interesting project. I have more technical question from the regulation point of view. So you have mentioned many times that you have their medical device regulation. But what you are designing in this project is not a device, a physical device. It's a platform. So why are you not mentioning, for example, digital therapeutics regulations, which are much better fitting probably to this specific platform? And I know that in Norway we have those regulations these days.
Yeah, so the question was about why I mentioned MDR and not the digital therapeutic platforms or other type of regulatory issues. So it's like short as like we were told this is a medical device, this is a software as a medical device. And it's not the platform which is part of the device, but it is actually sort of this clinical decision support system, which will be sort of the end result of the platform. Yeah, I forgot what the question was actually, but I hope I somewhat answered.
So, one more question.
Yes, it's just a follow-up with regards to medical device regulation. Are you working towards a specific class there to decide how you can use the system?
Yes. So regarding the medical device regulation, so we have our claim is that this is a so-called class 2A, which means that it is a medical device that is not making decisions, but it providing sort of guidance to clinicians who make the decision, take the responsibility. So that's the sort of the easiest class in a way, because like class 1 doesn't require to do, then it's not a medical device. But still like the workload for actually doing this, I can just like quickly show the slide. Like it's huge, there's a lot of documentation. So in this project, we realized this is not something we can do. So we have paid a company to basically guide us through the process. They're saying that these are the documents you need to fill out to satisfy this and this standard, and then we just like provide the information that nobody else than we do. But this is a really challenging part. Like it takes a lot of time, and it's a very unusual thing to do in an academic setting, I think.